Welcome to the day 10, guys. So, without wasting any time, let's jump into the problem. First problem that we are solving is constraint subsequent sum. Given an integer array nums and integer k, return the maximum sum of non-empty subsequence. Okay, we have to pick a subsequence of that array such that every two consecutive integers in the subsequence nums I and nums j, where I is less than j. Okay, great. The condition j minus k, j minus I should be less than equal to k is satisfied. Okay, so every two consecutive elements or every two consecutive integers that we pick for our subsequence should have will be having index I and j, and the difference of that index should be less than equal to k. Okay, not an issue. A subsequence of array is obtained by deleting some numbers of elements from the array, leaving the remaining array remaining elements in the original order. Okay, great. Some elements can be deleted, and that is our subsequence. Okay. So in my first solution, I have 10, 2 minus 10, 5, 20, and I took all the positive elements, and that was my answer. That is 37, right? The subsequence must not be empty, so we can choose. Okay, so here what I had was minus 1, minus 2, and minus 3, and k is equal to 1, and what we had was answer was minus 1 because we can't have a empty subsequence as our answer. Okay, in this particular solution, if I take the positive element, that is 10 and 20, the key won't satisfy that particular condition. So if we take 20 only, then okay, so the answer is 23 for this one. Why the subsequence is 10 minus 2 minus 5 and 20, so 10 plus 20 30, and then we have this. Okay, so there are cases where we also take negative elements, right? So initially what I was planning was in my mind that if we were taking only positive elements, then what could I have done was show you here. If I was only taking positive elements, what I was thinking was I would just move a pointer in my array. I would just move a pointer in my array I that would just sum positive indexes, right? And whenever I encounter a negative index, just like here, when I encounter minus 10, in my map, I will store the positive sum that would be 12, and the last index where this positive sum was encountered, that was at index 1, right? And then in a similar case, 5 and 20 would be here, and the particular sum would be 5 and 20, the sum is 25, and this particular sum ends at index 0, 1, 2, 3, 4, ends at index 4. But then I won't be able to connect this. So what could I have done was use a prefix and suffix sum and then connect these based on index. But as seen in the last test case, there are cases where we have to take negative integers also, right? Here we have to take minus 2 and minus 5 for our answer. So in such a scenario where I have to take negative integers also, it becomes I have to take positive integers. That is the case. I have to take positive integers at any cost. If that particular index satisfaction is there, but if seen there, I have to take positive integers at any cost, right? So what can I do is this 10 can be connected with this 2, right? Because the difference of the index is less than equal to 2, less than equal to 2, right? Now this 10 can be also connected with this minus 10, right? Why? Because the difference is still less than or equal to 2, right? But this 10 can't be connected to be this 5 because the distance become greater than 2. So we won't be able to take this 5. To take this 5, I must connect to this 2, right? So what I see is options, right? And whenever I see options, I somewhere try to, in my mind, create a recursive solution for this. I think of recursion, that if I can solve this particular problem using recursion, because when it's options, that is something that we should be thinking, right? So at every index, it is not necessary that I always take the first element, because there could be a case where this first element is pretty large negative number, right? Something like, let's say, minus infinity, right? So I won't be taking the first integer always. So what I need to do is decide whether I take an integer, a particular index at a number at particular index or not, right? So that changes this question in two things. That at every index I have a choice to take that index or just move forward, right? I can just move forward. So here I have 10, and the remaining array is minus 2, minus n, and all this. Then again I will come at index 2. Now I have a choice whether to take 2 or not, right? I'm currently standing at 2. There are two choices whether to take 2 or not. If I take 2, then I have sum 12, and if I don't, then the sum will remain 10. But this minus 10 that is here has to be connected with this 10. That is, so for that I have to keep track of the previous element that I took also, right? Because here when I will go forward, there is minus 10, right? I have minus 10. Now to connect this minus 10, I have to uh, minus 10 is here also, right? Because in the both case I will just move forward. Minus 10 is here and minus 10 is here, right? But in both of the scenarios the previous number is different. I didn't take 2 here, so 10f, and because the 10 was the previous element for this, and but here the previous was different, right? Okay, great. So far I can think of a simple recursive solution of a take and non-take, and whenever I will go outside of my index, because of the base case of the thing, so the base case would be 0 in these kind of particular problems. The base case is generally 0, because if we go out of the side of the array, then there is nothing to add left, right? So from this particular small approach that we have thought of so far, let's try to build a solution. Okay, let's name it as int solve, right? What I will pass is vector int, that is nums, right? I was passing int index, right? Index I, and one more thing I need to pass is int previous. Why? Because as discussed earlier, there could be a case where the previous was 10, and there could be a case where previous would be 2, right? So I can pick different previous, right? So for that particular scenario, I have these two, right? Now what? If I is greater than or equal to n, then return 0. Base case, right? Now what I need to do is have to two choice, right? uh, Two choices, int take, and I will have another choice that is int not take. But before that I have to check a condition, right? That is, if uh, I minus previous is less than equal to k. If I minus previous is less than equal to k, then there are two choices. Those choices are int take, that is add nums I plus solve, will solve nums comma I plus 1, and then previous is changed to I, right? or num size, sorry, num size, no, I. Okay, right. I need to pass the index, not the number. Okay, and if I go with int not take, that would be solve nums I plus 1 still, but previous would remain same, right? Not changing the previous. Okay, right. This is, and every time we get this, I have to do two things. I have to make a result also, right? So let's create a result 0, and what I will do is just update my result here. Result is equal to max of take comma not take, right? And what will happen is I will just return my result because that would be the best answer. I just return my result because that would be the best answer, right? Now what I need is here int in, so I have to pass in, so let's just create it globally int in, and then I will just reassign it dot size. Okay, now what next is I have to call the function, so return, that would be solve and nums comma 0 for 0. Yes, for 0 index there exists no previous element, right? So it would be -1 for me. I have to denote that particular thing, that before 0 does not exist any index, so that would be -1, right? So what I can do is, if uh, previous is equal to -1, then also we will do the same. We have take and not take, because at the index 0 also, right, we can have a take or non take, right? Okay, so I will pass -1 here, right? And then let's try to run this. Let's see what happens. Okay, compilation error. What is the issue here? Okay, I have not passed the key, right? I have to pass the key. So instead of passing key, what I will do is, I can just create a, I can just pass the key, right? I can just pass the key int k comma k, and what will I have to do is comma k, then same here, right? Let's try to run this now. Okay, wrong answer. Why? Let's see. There's test case 2 which failed, right? So why test case 2 failed? Okay, this screen, right? Because s minus I try to take marks of take and non-take, right? So what will happen in this particular case? Let's see. We have this in the first index, it is -1 and it is -1. So I have two choices, to take or it non-take it. So if I don't take it, then I have -2 as my next choice, and if I take, then I have -1 as my choice, right? And then also we have -2 as our choice, but we have taken -1, right? Okay, now again here what I'll have is whether I take -2 or I don't take -2, right? If I take -2, then -2 is my choice, and I will come at -3, but -3 is still there if I don't even take it, right? And let's come here, we have the same choice here also. We have -3, and if we take -2, then it will become -3 total sum, and then again we have reached index -3, right? Now what can be done is Okay, we take minus, didn't take minus 2, so minus 1 will be there, right? So minus 3 could be taken or not taken, right? Could be taken or not taken, and same here, taken and not taken. If I don't take minus 3, then I would return 0, and then I would return 0, right? And if I take minus 3, then I would return minus 3 from here, minus 2 from here, so minus 2 would be returned from here, but it is 0, so 0 would be greater than minus 2, so 0 would be written as first choice from here side, and this side also all the numbers that are we having would be negative, so negative numbers would be written eventually, so 0 would be the answer. So the answer output is 0, but we have to return something. So what I can do is I can just create a integer a that will have solve nums comma 0 comma minus 1, right? And my k also, and let's do one thing. If a is equal to 0, then return the maximum value, right? I need to return the maximum value. I have to go in the whole array, traverse this once, and return the maximum value. Okay, can I do this? Yes, I can write this particular loop int I is equal to 0 dot I is less than n dot I plus plus, and I have to also create a max, right? And max c, that would be initialized with int min. What will happen is max c would be, let's initialize it with minus 1. Max 0 is equal to max or max c comma nums I, right? And then to what, return max c after the loop is completed, right? Else what will happen is just return a, and let's see whether it works or not. I made some errors or something like that. Okay, it is working. Let's try to submit this code. Okay, so we have a TL here. Okay, that was to be expected that we will be having a TLE. Now I have to convert this particular problem to a better solution, right? What I need to do is, just a second guys. Okay, I need to convert this particular problem into a better solution. Well, I can try to memorize this particular code, right? I can try to memorize this particular code. To memorize a code, what are the that are changing in this code? If I look closely, there are two things that are changing. That is index. Index is the first thing that is continuously changing, but the previous is also changing in this code, right? This there is index, and we also have previous. So index and previous both are changing. Let's see what is the constant size nums k 10 to power 5 and 10 to power 4 10. So the issue is, if I try to create a DP of this particular size, it would be pretty pretty big, and that would just lead to overflow. So I can create a DP of this size, and I have index and previous that is changing, right? I have index and previous that is changing. In these type of scenarios where I don't have that much amount of space and there is a condition to overflow and there are more than one state that is changing, then what I try to do is represent either both of that state in a binary form, but in this particular case the binary form won't lead to uniqueness because I don't have the particular. So I would do what? I would convert this into a string. I can create this into a string. Definitely I can create this into a string, or yes, I can create this into a string, right? I can create this into a string. I press previous. It is a complete string whether I have seen this string or not, right? I have to check whether I have seen this or not. This particular combination of I and previous, whether I have seen or not, right? So for that, I would just add another map that will allows me to store string and integer whether it is being seen or not. Now what I need to do is whenever I come here, I will have a string s that would be my to string my current I and plus, and let's create a and then have a plus again, then I will have to string my previous, right? Okay, so I converted this into a string. Now I also need to check if mp we dot find is not equal to mp dot end, right? If it happens, then return mps. Whatever was stored here, just return that, right? Or else what will happen is we will completely solve this, and in mps I will have my result, right? In mps I will have my result. Okay, so far it's good. Now let's try to run this whether it works or not. Okay, it works. Let's try to run this. Okay, only 10 more test cases passed from the last time. Last time we were able to pass 8 test cases. This time we are able to pass 18 test cases. And the earlier time complexity that was of recursion was 2 to power n, right? And our memorization is not working, right? The code of memorization is not working. So let's first comment this out because we we are not doing well with complexity even with memorization. Okay, great. Okay, now if the memorization is not working, then what should I do? I should try for tabulation, right? Okay, I should try for tabulation, right? Let's go for tabulation. But before we go for tabulation, let's see what how I will build the tabulation code. I have this particular array, right? At every index, okay, let's go for this. At every index, I have a choice whether to pick it or not, right? At every index, I have a choice whether to pick it or not. But how will I? How will I? solve this in tabulation code, because this particular part is easy because I have to connect this index with this previous one, right? I have to connect this index with the previous one or the other previous one which satisfy this k, right? But for the zeroth case, what will be the answer, right? That is the base case that I have to think. So for the base case, according to me, for t0, the best answer would be uh, t0 itself, right? If it's even a negative number, then at t0, the best answer should be the negative number itself. Uh, if I have -1, -2, -3, let's just get this one also. If I have -1, -2, -3, then the best answer at this index is -1, right? If I put 0 here, then that won't be a valid solution, right? If I put 0 here, then that won't be a valid solution, because we have already seen that we don't have to return 0, we have to return value, some value, any subsequence, some value. So in this particular one, -1 is the answer. So at index 0, the best answer should be 10, right? Mm, why at only index 0? Because if I place 0 here and 0 here in my TP, then there would be issue, because 10 is here, then I connect here, then I won't be taking -2, then it would remain 10, and I will connect this, and then the similar case would happen. So I can't put 0, I can't initialize my TP with 0. I have to initialize my TP with the value itself, right? I have to initialize my TP with the value itself, right? But there is one thing that could be done, that is, uh, I will just have to update the values. If it is 10 and this is -2, then for the 10 the answer would remain 10 because there is no previous element existing there. But for -2, I will check with 10 and update the best sum here. So for -2, the best sum is 8, right? Okay, so the best sum is 8 here, right? Now when I come to this -10, what is the best solution here? There are two things to which I can connect this -10, right? Either this -10 could be -10, right? That is not good. If I take -2 only with this, it would become 12, right? Oh, sorry, -12. That won't be good. And if I connect this with whole, then it would be 2, right? And I guess 2 is the best answer for this, if because this is a whole connection, that is 2. And then in a similar case, I come to -5, and best answer for -5 is -3. The best answer for -5 is -3, right? Or there is any better answer? I am saying is this is -5 and this is 2, so it will be 3, -3, right? But if I connect this -5 this with this 8, because this key condition is satisfying with this, so if this -5 is connected to this 8, then the answer would be 3, not -3 but positive 3, right? So at -5, the best answer comes out to be 3. Now when I come to 20, I can check with all the valid ones, that is k is equal to 2, that would be 22 or 23. Then the 23 is the best answer, and that is my solution, right? So what I have to do is, just let's comment this particular part, right? I have to learn that particular way in which people comment. They pick a particular section of code and then they commit that whole section in just one go. I have to search internet for that particular thing. Okay, just no, yeah, no, just comment this one also, right? Okay, let's comment this one. Okay, okay, and let's comment that a part also. Okay, okay, I have commented the a part also, right? So now what I have to do is write a DP code. I can just vector int DP, uh, vector int DP, right? vector. Okay, guys, just a second. Sorry for the delay, guys. Okay, so what I was going to do, I was going to create a db vector, and this time don't have to worry about the size because it would be just n. And now in the db, what I will do is I will start from index 0. No, I have to first initialize my db. Okay, I have a dbn. Just say we have 0 here. Okay, for just timing, and for int I is equal to 0, less than n dot I plus plus. Do what? dpi is equal to nums I, right? That is the current best, and that is the current best, right? Okay, now what? After selecting the current best, what I need to do is go in the db. I will start from index 1 because there is nothing to check. There's nothing to check at index 0, right? Now for int I is equal to 1 dot I is less than n dot I plus plus, do what? uh, One thing, that is dpi is equal to max of, no, I have to iterate back, right? For int j is equal to I minus 1 dot j, uh, j is previous index, right? So I minus j is less than equal to k, and the j is greater than equal to 0, right? Then do what? J minus minus. These are the two basic condition that I needed to check. Okay. Now what? dp of I would be max of dp. Just a second, guys. Okay, let's resume the particular part. It was just little bit of work. Well, we were at dpi, right? We were at dpi. Now, what I need to do is I need to add nums I, and that nums I would be paired with dp, uh, dpj, right? dpj paired, right? Now what? In this particular scenario, there is not it is not necessary that the best answer lies at the last index, because in these kind of cases, what if the last index, the number at the last index was something minus infinity, right? So we would not take that, and since we are not taking that, uh, there could be a case that there was some earlier number that was greater than that, right? So for that sake, I will take result again, and I will initialize it with my dp0 only, because that is the best answer currently. After that, I will just initialize equal to max of result from dpi, right? And then I will just return the result. Okay, so far so good. Let's see what it looks like. Let's try to run this. Let's see what happens. dpn comma 0. It says n is unknown, y n is equal to num size. It is there. It is now it has and then the num size, right? Okay, this code is just totally outside of the bracket. That is the issue. So this is control X this particular thing, and then what we'll do is just paste it over here, right? And similarly, I'll just have to take this also and put it here. A little bit disturbed code. Let's see whether it works or not. Have I get indentation errors? No, I didn't get indentation error. Let's see what happens when I submit it. Again at TLE we were only able to pass two more test cases from our memoized code. The time complexity of this one is order of n square, right? I have a order of n square time complexity, and yet I am not able to pass more than 20 test cases, right? So now what will happen? Then we have to solve this particular problem either in order n or either in order n log n, right? For that particular case, the first thing first is I have to remove this extra loop or decrease the complexity of this particular loop, right? Mm, I have to remove this loop, right? In these kind of scenarios where you have to remove a loop in a DP problem, try to use a DQ. Try to use a DQ because DQ is a structure that is used in these kind of problem that arise. Let's see whether we can use it or not. And this particular DQ part comes from the solving of problems that you have done. I mean to say I have dealt with many problems. So this kind of intuition directly comes from there that we have to remove an extra loop and then we have to replace this particular with some other data structure, right? That can more efficiently solve this particular part, right? Now, in many of the cases, that data structure turns out to be DQ, DQ or prefix sum array or something like that, right? Given an array integers, I have this integer key return. So every time, what I am trying to do is I am trying to get a number I, and pair it with what the best answer, right? I had this 20. I had to pair this 20 with the best answer. That could be either the 3 or either the 2, right? Now, if I have a queue, if I have a queue, if I have a queue that has the best answer, okay, so the queue would work. DQ could work with some optimization changes, but I think the best structure would be a priority queue, right? Because I want the max element to be at the top, right? And what is better than a priority queue? We can use a multi-set. A multi-set could be used, but I would also, but I would consider to use a priority queue here. I can use a priority queue, but I have to also track the index because I have to maintain this k constraint that the value the index should be less than equal to k. The difference should be less than equal to k, right? So what can I do is I can hold the maximum sum seen so far and the index of that. This is 0, 1, 2, 3. The at index 3, I've seen some 2 at index 2. I've seen some 8 at index 1 and some 10 at index 0, right? Now, when I am working with the priority queue, 10 comma 0 would be at top, 8 comma 1 at second position, 3 comma 3 at third, and 8 comma 1 at fourth, right? Okay, so and this particular index won't satisfy the difference, so this would be popped out. This particular index also won't satisfy the difference, so it would be popped out. And the top answer, the first top answer that satisfied the condition would be the best answer, right? Okay, so let's do this. Let's create a priority queue, guys. Let's create a priority queue. I have this whole broken structure. Then what I need to do is I need to create a priority queue, right? Priority queue, Priority, priority queue. Now I need what? I need two things, int, comma, int, right? So I can store it in a pair. So for that particular thing, I would just do type def is equal to pair int, comma, int. Let's call it p. Let's call it p. Now what will I do is priority queue, capital P, and vector also that has capital P, and then just call it PQ, right? Now what will happen is at first, after initialize DP, what I'll do is pq.push. What is to be pushed is dp0, comma 0, the number itself. Best so far, right? Now let's eliminate this particular loop, and for now let's just comment it out. Now what I'll do is for int I is equal to 1, I will check while not pq dot empty until unless the queue is not empty, and pq dot top dot second is the index, and it would be a previous index. So I think the I should be here, right? I minus pq top dot second is less than equal to k. If it is so, no, is greater than k. Okay, so I will just do this is greater than k, because the difference is greater than k. Then do what? Do pq dot pop. Then we can't do this. We can not have this in our pq anymore, right? Right. Now pq.pop has been done. Now what I can do is I can just have result. Still the result. No, first I need to update a dp, right? dpi would be max of dpi, comma pq dot top dot first, right? Plus the dpi, right? Because that would be holding the best sum. Okay. So instead of dpi, well, we can use num_sci. dpi would be little bit not that good. So let's just replace it with num_sci. Okay, now I have num_sci. I'm adding the pq top first with num_sci, and then I have updated the dp, and do what? pq dot push, because this would be pushed in the queue. So dp dot I, dpi, comma index itself, right? Now what I need to do is just update my result again, and result this time would be max of result, comma dp of I, right? And then I will return the result, right? Then I will return the result. According to my guess, this should work. Let's try to run this. So there is no compilation error. Okay. Okay. We were able to pass this. Yes, we were able to pass this, right? Okay. This problem was able to be solved. Now let's move to our next problem. Okay. Moving on to our next problem, let's just say what is it is. Count vowels permutation. Given an integer n, Your task is to count how many strings of length n can be formed under the following rules. Each character is a lowercase vowel a, e, I, o, u. We have these five vowels. Each vowel a may only be followed by an e. Each vowel a, okay, just each vowel a should only be followed by e, right? Each vowel e may only be followed by an a or an I. Each e should be only followed by an a or an I, right? Great. Now, each I may not be followed by another I. May not be followed by another I. I not followed by I, right? Okay, great. So O may only be followed by I or a U. That is right. Or a U, right? O by only a I or a U, right? And then finally we have U may only be followed by an A. U by an A only, right? So what can I clearly say is that we have a choices. We have lots of choices, right? Now let's see what the real problem is saying. Given an integer n, your task is to count how many strings of length n can be formed. We have to form strings of length n with these conditions, right? Now this is clear cut recursive solution because we will start from n and we have choices. But how we'll work with these choices, that is the thing. Let's see. If n is equal to 1, then a, e, I, o, u is the answer. When n is equal to 2, we have a, e, we have e, a, I, e. So I can be followed by any character apart from I itself, right? So instead of writing this particular thing as I should not be followed and by an I, what can I say is I can be followed by all the remaining characters, all the remaining vowels, right? A, E, O, and U. All four are allowed, right? Okay. So initially, let's think I have an empty string initially, right? And I have to create a string of size n. I have how many choices at the first time? At first index, I have one, two, three, four, five choices, right? That is A, then E, then I, then O, and then a U. Then, if I have a as my first character, I have n minus 1 here with all these, then I can have E as a choice because E is the only choice here, right? So I can only take E, and this would just decrease the size to n minus 2. But at E, I have two choices, that is A and I, right? That is EA or EI, right? This is AE. Okay, so I can keep going down and making the choice, right? But the particular fact is, when will this particular stop? The this could stop. Either I can decrease the size, or I could just make it like count the size. I can just, let's say, if I decrease the size with every count, then when the size becomes zero, n becomes zero, then I have a valid answer, right? So this one seems to be pretty easy, right? Okay, so what I need to do is just need to solve this, right? Let's try to solve this. I have an int solve here. What I have to pass is just the character that I am starting with, int ch and int n, right? Now why character? Because I have the five choices, right? So I have to pass five times, right? And just do with one character only, right? I have to do it with five different characters. Okay, great. Okay, so my base case is if n is equal to 0, then return 0. There's no, there's no, if n is equal to 0, then return 1, right? I have found a valid answer, right? Because we were able to find a valid answer and reached 0. Now, if current character is A, then what will happen is I have to find the ways, right? So in this case, I will do one thing, that is I will create a new variable, that is int result, that would be initialized with 0, and result ch is equal to result plus is equal to I will again call the solve, right? I will again call the solve, and how many, n minus 1 with e as the character. I will call the solve with e as the character. If ch is equal to e, then what will happen is result would be plus with what? Mm, result would be plus with solve of n minus 1. 1 is a, and then I also have this particular one, right? We'll also have solve n minus 1 comma, it is I, right? I. Okay, we have raised so far. C is equal to a I. Let's see what happens if character is equal to I. Then what we'll do is result plus equal to solve n minus 1 comma a plus solve n minus 1 comma e plus solve n minus 1 comma o comma, sorry, solve n minus 1 comma u, right? I'm taking all the remaining 4 variables. Now a e I, let's go. C is equal to 0. What will happen is, no, not 0, it's o, right? It's o. What will happen is result plus equal to solve n minus 1 comma I plus solve n minus 1 comma u, right? And finally for u I can just write it as else result. Okay, so just write it as else f, right? Result plus equal to solve n minus 1 comma a, right? Now what I will do is return result, and here I will just call my solve return. No, I have to call it 5 different times, right? I have to start with a, then e, then I, then o, then u, right? In this particular way I have to go. So for that scenario, what I will do is I will create int answer equal to 0, and then I will go for int I is equal to 0 dot I is less than n dot n, no, 0 1 2 3 4 5, I is less than 5, right? I plus plus do what? Answer plus equal to solve. What is it? It is it is it is n comma I, right? And then just return the answer. But there is one flaw that I have not taken care. I have not initialized them, right? Int a is equal to 0, int e is equal to 1, int I is equal to 2, int O is equal to 3, and int U is equal to 4. Now this should work according to me. Now let's see what happens, whether it works or not. I got a runtime error. Great. Where did the runtime error come from? Solve in CHN. What is the issue? Hmm, Did I pass the index right? Right, I passed the index. That is I is equal to 0, and that. Hmm, Why I am getting a runtime error? I really hate runtime errors. Hmm, Solve. Since the answer may be too large, return it in a model. So first thing first is let's change it to long, long. Right, guys? Let's just try to change it to long, long. Then result also to long, long. Right? And since our answer is too big to be dealt with, I will do modulus of capital M. But I have to declare capital M also. Constant capital M is equal to 1e9 plus 7. Right? This is the great number. Now I have to just do this particular thing every time. So why not just copy paste it? No, 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 no. Let's see what happens, whether it works or not, even with this particular change or not. What I'll do is mm, I can do a modeler here also, but I won't be doing that. Let's see whether it works or not first thing first. Still the runtime error process. Hmm The golden gold runtime error, right? Let's try to. Still the same. Oh, this time? No, I don't think this time. I just typed that, so why the error vanished. Okay, result. This is giving the runtime error. Why am I adding it? I don't have to add it. To just store it, right? All the valid answers come with one. Why would I just add it? Let's see. Still the runtime error. Where I'm getting the runtime error? Somewhere here again. Holy loop does not end. Okay, this one was left. Hmm. Why I am getting runtime error still? I have to learn to work with runtime errors. Need someone to teach me how to work with these. Adding syntaxes, stack overflow or address. So it is going, it is saying crying for stack overflow, right? This is crying for stack overflow. Okay, already modulus this. Return answer is also modulus this. Solve. Then what is the issue, man? What is the issue? Let's ask GPT to handle this runtime error scenario. Why runtime error? Okay, now I get it. This is the issue, right? I have to change it to I, comma n. Let's see whether it works with this or not. Still the runtime error, the same place. Swap the argument in your call with n minus 1. It's saying I have to swap it with n minus 1. Why? Why I have to swap it with n minus 1? Because I've taken my first character already. Right? Passing n minus 1 because we have already chosen the first. Let's try to run this. Okay, still the runtime error. Now I need to just end myself. Understand why still the runtime error persists. Now it's still saying stack overflow. Why stack overflow, man? Stack overflow. Mm, let's just add one more thing, that is this modulus capital M here. Let's try to run this. Okay, it did not work. Let's ask again. Why still runtime error? Okay, so it is saying because I am not using memorization or caching, that's why. Okay, so if I'm not using memorization and caching, then so are you. Let's see whether your code works or not. And it worked, right? Guys, his code worked, but mine did not. Why? Int answer because of that. And this was long, and this was int answer. Let's try to run this. See what is the issue. We'll track this down. Long solve why you are not working. Still the error. Let's see what is the issue. It is having long solve int character int n is equal to 0 base case. Same thing. Let's just copy his long. Why am I long? Let's see. Do. Long result. What I have long result also same. And what I'm doing, solve modulus m, result is equal to. Sometimes just don't know why Leetcode does this to me. I have this answer. Let's see why he said I was getting. His code is working, but my code is not. That is the issue. Even when he is using my code. Quite a issue, guys. Quite a issue. What is the issue? Mhm. Okay, let's do this. Answer first. Hmm. It still says there is a stack overflow here. I don't understand why there is a stack overflow here. Ah, there still. Let's ask GPT what is the issue. Line 9, this stack overflow. Shit, that is happening. Okay, I have done this shit. I have done shit. And this is pure shit. This is pure garbage. This is pure garbage. And I am a piece of shit for doing this particular piece of crap work that I have done. I am a piece of crap. Now this compilation error. Okay, just pass in -1. Ah, it got accepted. Let's try to submit this. What happens? Let's see what happens when I try to submit this. We get a TLE. We were only able to pass 5 test cases. But, well, that was to be expected. Now, what are the parameters that are changing in this, or what are the states that are changing? There are two states that are changing: my current character and my n, right? So, what is the size? We have 2 to the power 10 to the power 4, right? For n. Hmm. Well, we have to create a DB, right? Anyway, so let's create a vector, vector, that is int. Let's call it DB, right? Just for now. Let's call it DB, and if DB n and I n and ch. So ch already, I'll just call it chnn. That would be much better than n cons not equal to -1. Then return dp chn, right? Okay, we have chn. Okay, great. Now what will happen is, mm, this is dp, this is all dp good. What I need to do is I have to store the answer in dp, right? I have to store the answer in dp. So for that, I can just do is result, just have dp ch bracket n is equal to result, right? And here is the answer, but I have to reinitialize my db also right here, right? So db dot resize. What we have to resize is with, I have 5 characters, and then I have a vector, and vector, it would lead to overflow, and I don't want a overflow again. So vector and long, and then what I will have is n plus 1 comma -1, right? Mhm. Now let's try to run this. I hope it works. I hope it works. And then we get a compilation error. tp.resize 5 vector long n comma +1 -1. Okay, I think it should have worked. What is the issue? No matching member function. No matching member function. Okay, I created the dp of int size and calling it as long. So I hope it works this time. Let's try to submit this code, the DP code. Okay, so it got accepted. Pretty great. And guys, I would be ending the stream today here only. We were able to solve two problems, but we made some progress. Okay, let's meet you tomorrow.